The volatile. Oh, I've just noticed that appears to be the volatile ranges patch set. Oh, look, I didn't pick that up the first time I read that. So the idea here, and if you come from an application space, a higher level where you are used to dealing with garbage collected memory, the idea here is that of a weak reference. You have a data structure, some sort of cache, and if an element of that cache gets invalidated, it doesn't crash your program. And in Python and in Java, this is a standard thing that is available to you. If your program is running out of memory, you can dump any of these weak references, and the API is designed to be able to handle that. And the typical example, and I think it's the same one that they've used, is of a web browser. It has a JPEG image. You've got a page. There's a couple of images on the screen. There's one image that's scrolled off the screen. It's really nice for the browser to have that image that's not directly available cached in memory. So when you page down, it can quickly load that up. But right now, it doesn't technically need to be in memory. So this is a perfect example use case for volatile ranges. So we have seen this patch many times before. I think this is the 14th version of this patch. It has moved around whether or not it's going to be an extension to a current system call. POSIX fadvise, fallocate, fvrange, whether they're going to add new sysoctls for it, like madvise. There's many different ways that it could work.
There's a lot of ways this could work, and over the course of the last 2 years, they've tried all of them and rejected all of them, and I think they're starting to come back to earlier ones.
Yeah.
This is very much, this is a patch that has been in the work for several years. It's been rejected. People have complained about the way it's done. They've changed their mind and done it another way. I admire the perseverance that it takes to just keep working on this, even though somebody complains about every possible way of doing it. Although I imagine that's a fairly common feature of trying to introduce new things to the kernel.
Yeah, and it's good when you're looking to change the system interface. And I mean, this is memory allocation, so we have a pretty standard API for doing this, and certainly in the C world, that really doesn't change all that often. So you've got to think about backwards and forwards compatibility. Like, do you want to do it in such a way where only newly written code can take advantage of this, or do you want to write it in such a way that old code can take advantage of this just by hacking some stuff onto the side in a signal handler? So there's lots of different decisions that can be made. And it's really interesting. Like they do actually say in this story at some point that people are actually using this patch out of tree, and applying it to their own kernels, and using it. So at least in some point, some part of my brain is saying that we do actually have some use cases for this, and that should be...
People clearly care about it, and that's why they're using it out of tree. People clearly disagree about what the best way to do it is, and that's why this has been under heavy revision for several years and is up to its 14th version.
Yeah.
Now, the main point of contention about the best way to do this that's raised in this article is when I tell the kernel, you've allocated me this memory, but I've told the kernel it's okay if you need to claim it back later. What should happen when I next go and say, oh, what's in that memory? There's two things that have been suggested here. One is when you say to the kernel, by the way, is that memory still available? The kernel says yes, and you access it, or the kernel says no and you don't. And if the kernel says yes, then it contains whatever you put in it last time. The other, which to me is sensible, that's how I would expect it to work. It mirrors what you see in higher level languages, like garbage collected languages that provide weak references. The other suggestion here is that when you go to the kernel and say, give me back that memory, but the kernel has already allocated to something else, the kernel should give you back that memory anyway, but fill it with zeros. I don't know why you would want to do that. It seems like this is going to be a recipe for bugs because code is expecting the data that was previously there, but now it contains zeros.
And it's not a sentinel value. That's the big problem.
Yeah, it's if I say, kernel, please give me the memory I had before, and the kernel doesn't have it, but I need that memory to store things, then I really should be able to very simply go, okay, allocate me some new memory instead.
In my mind, the way that this works is that it doesn't actually invalidate the memory and it doesn't deallocate it. It just marks it as swappable. So if you're running out of RAM, oh look, this application has said these things, I can write these out to disk, and then the next time I pull it in, it might be a little bit slower to pull it back. And in my mind, that's a simpler way of dealing with this situation and has the lowest code changes that I can make.
That's not what I picked up from this article. This article is particularly saying that once you have told the kernel that you can have this memory back if you need it, the kernel is free to reclaim the pages and discard their contents.
Yeah. And that's totally the case. But if you make it so that it's free to discard the memory, but keep the address, but just push it to swap, then you don't actually have to write any code to grab it back. And all of the code to clear it out of memory and put it into the swap is kind of already there. So,
what about the example of not having swap?
Well, if you don't have swap and you've got memory issues, you've got bigger problems.
I'm more thinking that's the scenario you should be considering as well. You know, people might be using that where they don't want to have swap, but they do want to be able to just arbitrarily discard pages when they're not needed.
Yes.
Yeah, I think that's where this is useful, is when there is a possibility that you are going to run out of memory, which generally means because you don't have swap, alternately because you've also run out of swap.
Yeah.
And this is a way to tell the kernel, under that circumstance, you're allowed to throw away these bits of memory because I can easily re-get what I had stored there from elsewhere.
See, my problem with all of these things is that you really quickly get into a state where you just end up churning through everything. Like you've got a data structure there full of weak references.
If you're running out of memory, you've got other problems anyway.
And you keep dumping all of this stuff. So in my mind, I think the reason that they're sort of tumbling over the API and there's so much churn on how they want to do it is because there's not a clear example and use case.
Well, there are people taking this patch and applying it to their own kernel. I would like to hear to find out what their use case is, because that would be very useful for deciding what the default behavior should be.
Yes. This is certainly really interesting stuff. And stuff like this can, really significantly change the way. I mean, imagine if Firefox could tell it that, oh look, of these 500 tabs that I've got open, these 40 that the user hasn't visited for the past hour, you can have all that memory back and I'll load that memory back. Mm-hmm. Imagine how much better your system would be if Firefox only was using the memory of like your last 5 open tabs or something.
I tend to put lots of memory in my machine, so...
I do too.
I've got lots of memory on my machine and I run a lot of tabs.
And Firefox still uses it all up.
It's just delaying the problem.
Anyway, I think this is, it's a really interesting thing, and it's one of those things like it's interesting to think about, and there are different ways of looking at it,
and what the best way to look at it is depends on your use case, and we don't know what the use case of the people who really care about this is. And I think there might just be interest in this for interest's sakes in some respect, but the most interesting thing, is that the developer has basically said that
unless people make up their mind, he's going to have to put this on the back burner because his paid work is ramping up.
Look, fair enough. He's been working on it 4 years, heavily revising it, and
14th
people
version.
are still saying, no, that's not what we actually want.
Yeah, so, I'm sure we'll see this again. Thanks very much.